let's look at the geometric interpretation of the complex plane. So notice here, graphing this, if I plot that I've gone on the real number, the x-axis, the real number axis, and then the imaginary number. Okay, so you can see 1i, 2i, 3i, 2 i's. That wasn't funny. Okay. And so it's not really that much different as far as graphing, okay, as long as you have your y-axis as the imaginary number system. So if I want to plot something like z equals 3, square root of 3 minus I, then of course I need my pencil. Let's go purple. And so I would just simply draw this out. My real number is my square root of 3. Okay, so once again, this is the real and this is the imaginary. And so I would just go to wherever I think the square root of 3 would be. So let's just say it's right here. And then I would go down -1 because that's -1i, and I'd put me a point right here. And that's it. And that would be the actual point. Square root of 3, -1i. All right, if I'm looking at magnitude, so if we have the complex number system and we find the magnitude, okay, a lot of times this is called modulus, especially in computer science, of this complex number, and we denote it by these absolute value bars, is defined as the distance from the origin to a particular point, okay, so to the point xy. So in other words, this means the magnitude from the origin to the point, and this should look familiar, found by finding the distance. So because I can write my conjugates, if you remember, the x squared plus y squared, then this would be the same thing as the magnitude would be the square root of z times my conjugate. All right, so if we want to convert complex number to rectangular form, so from the complex number system to what you're used to, the xy form, when we write this in standard form, notice this is pretty easy because there's the x and there's the y. Okay, so that would just simply put it in there. If I want to convert now from complex to what we call polar form, okay, so remember polar coordinates kind of sort of. If you remember that if we looked at this as x over r equals cosine, then I just simply move the r to this side, so we get x equals r cosine theta, y equals r sine theta. Okay, so here it says if my r, so in other words that's my distance, my radius, is greater or equal to 0, and I'm between 0 and 2 pi, then the complex number may be written in polar form as this formula. So once again, the x being the cosine, the sine, okay, being the y, and then put the imaginary number, and then all they did on this step here was factor out the r, okay, where in this case, the magnitude, remember from the origin to a point is magnitude, well, that would simply be r. So if I want to write an expression for this square root of 3 minus I in polar form, then I can do this by first finding, so I want to first find r. So r would be the square root of 3 squared plus -1, because that's what's on the I. And of course, this would be the square root of 4, which would be 2. And then I can find sine theta, which, as a reminder, what happened, is y over r. And remember, looking at this, this is my x and this is my y. So that would be -1 over 2. And then cosine, which would be x over r, would be square root of 3 over 2. So what I'm looking for is I need to find the angle, that the theta that satisfies both of these equations. So I think if you look on your unit circle, you will see that's 11 pi over 6. Pause me and get your unit circle. You got it? Look. All right, get it. And so then my final answer, remember it's written in this form, cosine theta plus I sine theta would then be 2, way back up here, my magnitude, or my R, cosine 11 pi over 6 plus I sine 11 pi over 6. So in other words, all we did was we had to find the magnitude first, the R, and then based off of that, we could get our sine and cosine, and then we had to find where the angle is satisfied for both of these, the negative 1/2 sine and then square root of 3 over 2 to be able to get our angle. All right, if I want to plot a point in the complex plane and then convert from polar to rectangle form. So in other words, I want to plot this point. So let's go red. Let's get crazy, right? So in other words here, what I'm looking at is I want to plot my R theta, okay? And of course I'm going to end up converting this. So by looking at this, my R is 2, okay? So kind of sort of remember plotting, let's just write this out. Plotting polar. And so I go out, remember if this is polar, I go out 1, 2 units, and then I go 30 degrees. Okay, so that would be my point. All right, and then from here, I take this piece, and then the cosine of 30 degrees is what, square root of 3 over 2? You got your unit circle, you got to memorize. And then the sine would be, that looks kind of weird the way I wrote it, 1/2. Or now, as you can see, if I can cancel both of them, and I can, square root of 3 plus I, and then of course this is in my rectangular, it's complex but rectangular form because we know what X is and we know what Y is. And I think that's a good place to stop, so we'll finish up the next lecture.